Okay, geometry students, today we are going to talk about perpendicular bisectors and angle bisectors. So please turn to the front of your Chapter 5 notes and let's look at some definitions. Our first definition is perpendicular bisector. A perpendicular bisector is a line, a segment, or ray that divides a segment into two equal parts and is perpendicular to the segment. So if we have this example right here, we can see that this segment cuts the segment AC into two equal parts and is also 90 degrees, so that makes it perpendicular to AC. The other vocabulary word we're going to look at today is an angle bisector. An angle bisector is a line, a segment, or ray that divides an angle into two equal parts. For example, we have this angle bisector. We call this D out here. This ray cuts the angle BAC into two equal parts so that BAD is congruent to DAC. Keeping those in mind, let's turn to page 4 of our notes, and we'll continue our notes for today. Okay, looking at perpendicular bisectors, a perpendicular bisector theorem states that if a point lies on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segments. Therefore, if CD is perpendicular to AB and AD is congruent to DB, then that means that AC will be congruent to CB. The converse of the perpendicular bisector theorem states that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of that segment. So therefore, if AC is congruent to CB, then CD must be perpendicular to AB, and AD would be congruent to DB. Okay? Let's take a look at some example problems. Number 1, it says to find the value of x. Since we know that this is a perpendicular bisector because these two segments are congruent to each other, we can say that 7x plus 24 is going to be equal to 13x minus 48. Now we use our algebra skills to solve. Okay? If we subtract 13x from both sides, we get a negative 6x. And if we subtract 24 from both sides, we get a negative 72. Then when we divide both sides by negative 6, we end up with an x equals 12. And that's what we were told to find, is an x equals 12. I want you to pause the video now, and I want you to try number 2. Okay, check your work for number 2. You should have gotten x equals 2. Let's take a look at number 3. Number 3 tells us to find RS. Tells us to find the distance between R and S. So because we know that RT is a perpendicular bisector, because Q, T, and TS are congruent, then that means we can set 7x minus 22 equal to 4x plus 5, and we can solve for x. Our first step is to subtract 4x from both sides. That gives me 3x minus 22 equals 5. Then we're going to add 22 to both sides. And that gives me 3x equals 27. Divide by 3. And we get x equals 9. So now we know what x is equal to, but that doesn't answer the question, what is RS equal to? So we're going to take this 9 and we're going to plug it in for x to figure out what RS is. So 4 times 9 plus 5. 4 times 9 is 36. 36 plus 5 is 41. So that is the length of RS. Okay, I want you to pause the video and I want you to try number 4. Okay, hopefully you should have found that 4 is equal to x, and when you plug that 4 in for EG, you found that 2 times 4 plus 11 gives you 19, so EG is equal to 19. Okay, I would like for you to do number 6 and enter that answer into Edpuzzle. All right, let's turn to page 5 and talk about angle bisectors. Okay, when we're talking about angle bisectors, if AD bisects angle BAC and AB is perpendicular to BD and AC is perpendicular to CD, then BD is going to be congruent to DC. The converse of the angle bisector theorem states that if a point is on the interior of an angle and equal distance from the sides of the angle, then the point is on the angle bisector. So if BD is equal to DC and AB is perpendicular to BD and AC is also perpendicular to CD, then AD bisects BAC. All right, let's look at some examples. Take a look at number 1. We have to find the value of x. So because we have 2 angles that are congruent to each other, we can assume, and we have these perpendicular lines here and here, we can assume that these 2 segments are equal to each other. 4x plus 30 is equal to 9x minus 5, and we can solve. Subtract 4x from both sides. That gives me 30 equals 5x minus 5. Add 5 to both sides. That gets me 35 equals 5x. Divide by 5. We get x equals 7. And that's what they ask us to find. I'd like for you to pause the video and try number 2. Okay, because we have perpendicular segments here and here, and we have 2 segments that are congruent, we can assume that this line is an angle bisector, and this angle and this angle are congruent to each other. So we set them equal to each other and solve, and we get x equals 10. All right, let's take a look at number 3. They want us to find AD. Again, we have the situation where we have 2 angles that are congruent, and we have 2 sets of perpendicular lines. So we can assume that 13x minus 4 is going to be equal to 8x plus 11. Then we can solve. So I need an x in there. Okay, subtract 8x from both sides. And I get 5x minus 4 equals 11. Add 4 to both sides. And I get 5x equals 15. Divide by 5. And I get x equals 3. Okay, they didn't ask us to find what x is. They asked us to find the length of AD from here to here. So we can take that value, 3, and plug it in for x. So AD, segment AD, is equal to 13 times 3 minus 4. So AD is equal to 39 minus 4. AD is equal to 35. I want you to pause the video and I want you to try number 4. Okay, seeing as we have these 2 segments that are congruent and we have perpendicular lines here and here, then we can assume that these 2 angles are congruent to each other, and we set them equal to each other and solve and find that x is equal to 7. We take that x and we plug it in to find the measure of angle XWZ, this guy right here, And we find that the measurement of angle XWZ is equal to 24. Okay, I want you guys to do number 6 and answer in Ed Puzzle.